Hello guys, welcome to today's video. In this video, we're going to talk about a branch of differentiation, which is the quotient rule. And the formula for quotient rule is given as the y, the x, which is equal to v du dx minus u dv dx all into v squared. So this is the formula for quotient rule, and we're going to take an example under this. So we're given a question. The first example we're going to take is given the question y is equal to x all into x plus 1. Now we're going to say let our u be equal to x, then our v be equal to x plus 1. So we're going to differentiate u with respect to x and v with respect to x. So we are going to have du dx. When you differentiate x, you're going to have 1 because x is raised to the power of 1. 1 minus 1 is 0. So anything raised to the power of 0 is equal to 1. So we have, when we differentiate dv dx, when we differentiate v with respect to x, we're still going to have 1. Now putting this into this equation, which is dy x will now be equal to, we have v du dx minus u dv dx all into v squared, and our v is what? X plus 1, so this will be into a bracket. Then our du dx is given as 1, subtracting our u is x, then our dv dx is also 1, all into v square, and our v is what? X plus 1, so this will be x plus 1 all square. So we're going to subtract this, expand. 1 times x is x, 1 times 1 we're going to have 1, negative, x times 1 is what? X, all into x plus 1 all square. Then we're going to have x, we're going to call it like terms, so we have x minus x, which is 0, 0 plus 1, we're going to have 1, all into x plus 1 all square. So these are answer for this question using the using the quotient rule. And for you to know when to use quotient rule is when the question is in dividing form. When you are dividing a function from another function or equation from another equation, is when you use the quotient rule. And we're going to take another example right now. Okay, another example. We have a question given as y is equal to 1 into x squared plus 4. So our u will be equal to 1. Then we say let our v be equal to x squared plus 4. So differentiating u with respect to x, which is not written here, and v with respect to x. So we are going to have du dx. So when you differentiate this, it's going to be 0 because it's a constant. And when you differentiate this with respect to this, when you differentiate x squared, we're going to have 2x, and when you differentiate a constant, automatically 0. So putting it into the quotient rule formula, which is the y, the x, which is equal to v du dx minus u dv dx all into v squared. So we're going to have our v is x squared plus 4, all into du dx is 0, subtracting our u is given as 1, then our dv dx is given as 2x, all into v square, and our v is x squared plus 4, then all into what? Square. So expanding, 0 and 0 multiply this bracket, automatically it becomes 0. So we have 0 into minus 1 times this, we're going to have minus 2x, all into x squared plus 4. When this multiplies, we're going to have this, and when this multiplies, we're going to have this. all into this all square. So 0 minus 2x, we're going to have minus 2x all into x squared plus 4 all square. So this is the answer using the quotient rule. And we're going to take another example which involves trigonometry. So we're given a question, y is equal to sine x all into x squared plus cos x. So our u is equal to sine x, then the v is equal to x squared plus cos x. So differentiating with respect to x, we're going to have du dx will be equal to, when you differentiate sine x, we're going to have cos x. So we're going to differentiate v with respect to x, so it's going to be dv dx is going to be x squared. When you differentiate x squared, we're going to have 2x. When you differentiate cos x, we're going to have minus sine x. So here is going to become minus sine x. Now putting it into the formula for quotient, which is the y dx, which is equal to v du dx minus u dv dx all into v squared. So we're going to have our v is giving us x squared plus cos x all into du dx is cos x minus our u is giving us sine x all into dv dx is 2x minus sine x all into our v squared becomes x squared plus cos x all square. So expanding this, we're going to have this multiply this. We want to open this bracket, so cos x multiply x squared, we're going to have x squared cos x plus cos x multiply cos x will become cos square x, then minus sine x multiplied 2x, we're going to have 2x sine x, and we have minus sine x multiply minus sine x, we're going to have plus sine square x all into x squared plus cos x all square. Okay, so we're going to collect like things. So here becomes x squared cos x minus 2x sine x plus sine square x plus cos square x all into x squared plus cos x all square. Now note that, sorry, we have to note that sine square x plus cos square x is equal to 1. So we're going to have x squared cos x minus 2x sine x. So in place of sine square x plus cos square x, we're going to put plus 1 all into x squared plus cos x all square. Okay, so this is the answer when we differentiate the fraction sine x divided by x squared plus cos x using quotient rule. I really hope this video is really helpful.